Okay, let's unpack this. Today, we're diving into a system called Noctua. It's described as smart infrastructure management and central monitoring software, developed with Birtech engineering.
That's right. And our mission really is to understand how this thing works, how it pulls together real-time monitoring, analysis, optimization of basically everything, physical assets, digital ones. The goal being better security, better efficiency for you, the user.
Sounds ambitious.
Yeah, the claim is from the smallest business to multi-location international companies, which is quite a range.
So whether you've got one critical server closet or, I don't know, a global network of data centers.
Exactly. The underlying need for reliable monitoring is the same, and that's reflected in the usage areas they list. We're talking data centers, obviously, but also production facilities, cold storages, even specialized things like vaccine or medicine cabinets.
And technical service rooms, UPS, generators, that kind of thing. Critical infrastructure.
Precisely. It covers a lot of ground where failure is just not an option.
Okay, so to manage all that, what does it actually monitor? What data is it pulling in?
Well, the basics first. Environmental sensors, temperature, humidity, smoke detectors, flood sensors.
Standard stuff for facility monitoring.
Right, but then it goes deeper. IT devices, UPS systems, PDUs, the power distribution units, climate control systems, anything speaking Modbus or SNMP, which are common industrial and IT protocols.
So talk to a lot of different equipment.
A lot. And it even integrates physical security assets like cameras and NVRs, biometric access control systems.
Ah, okay. So it's trying to be a truly unified platform, not just environmentals, not just IT, but kinda.
Yeah.
Everything together.
That seems to be the goal. And that leads into one of its core features, this idea of hierarchical management.
What does that mean in practice?
It means you can model your entire operational structure within the software, from the top level, like country, down through regions, specific sites, buildings, floors, rooms, even individual racks or components within a room.
Wait, okay, so if I have multiple sites, say a data center in one city and a cold storage facility in another, how does it handle rules? Like, a temperature alarm means very different things in those two places. Does it get messy?
That's actually where the hierarchy helps. You define rules at the appropriate level. So a rule for the cold storage applies there, a different one for the data center applies there. It provides context, makes it simpler, paradoxically. You don't have a million confusing global rules. It keeps things traceable.
Okay, that makes sense. Now, you mentioned intelligence. There's something called computational super sensors. That sounds advanced.
It is pretty neat, actually. It's essentially a way to create new virtual sensors without any coding. It uses a drag and drop interface.
Virtual sensors? How?
By combining data from real sensors using logic like and/or operators or mathematical formulas.
Can you give an example?
Sure. Let's say you want to detect a specific type of air conditioning failure, maybe a refrigeration fault. You could create a super sensor that only triggers an alarm if, say, both the room temperature goes above 28 degrees Celsius and a separate airflow sensor confirms the AC unit's fan is actually running.
Ah, I see. So if the fan isn't running, it's a different problem. If the temp is high but the fan is off, maybe the unit just lost power.
Exactly. But if the fan is running and it's still getting hot, that points more specifically to a cooling mechanism failure.
That sounds like it could cut down massively on false alarms or ambiguous alerts.
That's the idea. Context-aware alerting, filtering out the noise.
And this ties into another feature, right? The time-based alarm rules.
Yes. This adds another layer of flexibility. Alarm thresholds aren't static. They can change based on time. Think about it. A certain server room temperature might be perfectly acceptable during peak daytime operation.
But may be concerning if it stays that high overnight when load should be lower.
Precisely. Or maybe thresholds need to change seasonally. 25 degrees might be a minor warning in summer, but a critical issue needing immediate attention in the dead of winter if the heating failed.
So the system adapts its sensitivity to the operational context, whether that's time of day, shift patterns, or even the season.
Right. And this isn't just about alarms. There's also remote control capability mentioned. Adjusting parameters, triggering outputs.
It's like remotely turning on a backup fan or adjusting a thermostat set point.
Potentially, yes, depending on what systems are integrated. And alongside that, there's rack and asset management.
Okay, what does that involve?
Visualizing your equipment within cabinets. Seeing where devices are physically located, tracking assets, maybe even optimizing space or power capacity within the rack itself.
Bringing the physical layout into the digital management space.
And that visual aspect is crucial. They talk about centralized dashboards, of course, showing all the key numbers, but also 2D visualization with heat maps.
Heat maps. Like weather maps, but for a data center.
Kinda, yeah. Imagine seeing a floor plan of your server room, but colored based on temperature readings from sensors. You can visually identify hotspots, areas where cooling isn't effective, maybe where airflow is blocked,
Yeah.
before it causes a device failure.
That moves beyond just lists of numbers. You're actually seeing the environmental conditions.
Exactly. It's about making the data intuitive and actionable.
Okay, so we have all this data coming in, smart logic filtering it, dynamic rules, visualization. How does it handle getting critical information out, notifications and reporting?
It supports multiple channels for notifications, email, SMS, phone calls, mobile app pushes, web alerts, even SNMP traps to other management systems. And the configuration for these is apparently quite granular. You can set preferences at the overall system level, per sensor, or even specific to individual users.
So the right person gets the right alert via the right method.
That's the goal. But beyond immediate alerts, the advanced reporting seems key.
What makes it advanced?
It's not just logging events. It's designed to let you analyze historical data.
Right.
Look at past incidents, how quickly personnel responded, even analyze system usage habits. The idea is to use that data to optimize safety and operational procedures, find patterns, improve responses.
So it's about learning from the past to improve the future, moving from just reacting to incidents to proactively managing the environment.
You see, it's moving from passive monitoring towards, well, the source material uses the term operational dominance, continuous optimization.
So what does this all mean when you put all these pieces together?
It means you're aiming for a system that gives you comprehensive control, minimizes noise, and provides the insights needed not just to fix problems, but to prevent them and run things more efficiently.
And a big part of that noise reduction seems to be avoiding what they call alarm pollution.
Right, using smart event detection. An alarm doesn't fire the instant a threshold is crossed. There's delay management. An event might only be generated if a condition, say, high temperature persists for a defined period, maybe 5 minutes, 10 minutes.
Filtering out those brief spikes or momentary fluctuations that don't actually represent a real problem.
Exactly, which really cleans up the operator's view, letting them focus on sustained, meaningful events.
Which brings us to a final thought, perhaps.
Yeah, it makes you think, doesn't it?
Yeah.
If you could filter out all that noise, all those instantaneous, maybe unimportant blips, what underlying issues might become visible? What hidden maintenance needs or optimization opportunities would you discover if you were only looking at data representing sustained, context-aware conditions?
That shift from reacting to momentary changes to understanding sustained states, that could be quite profound for managing critical infrastructure.
It really could. It's about seeing the real signals through the noise.